All right, here are the learning targets for our first quiz, which is going to be on Tuesday next week. Today's March 1st, so let's see, 1, 2, 3, 4, 5, March 5th. All right, so on March 5th, our quiz is going to look something like this. So let's go and start with the easy ones. So basic, I can find area and arc length of a sector of a circle given degrees or radians. Find the area of a sector with a central angle of 37 degrees and a radius of 20. So notice they give me degrees, so I need to use the formula for degrees. And again, the formula for degrees is not in the packet. It's not in the packet. You just have to know it. Okay, so the area of a sector, area, I know it has to do with pi r squared, but I don't have a whole circle. I have 37 out of 360 degrees. That's the fraction of the circle I have, and I'm going to times that by the area of the circle, which is pi times radius squared. And then you are allowed to use a calculator on this part, so let's go ahead and I can just put it into my handy dandy calculator. So I have 37 divided by 360, get that, times that by pi, got that, and then I can times that by 20 squared, I know is 400. Times that by 400, and I get my area. So three significant figures would be 129 centimeters squared. So do make sure you're using your proper units on this, okay? Please do use proper units. Actually, that kind of reminds me, for those of you who just watched the last video, I forgot to put units on these. AB, that would be centimeters, and the radius is 3 centimeters. Oops. Sorry about that. Just remembered. All right. Sorry. Okay, back to this. The arc length caught by a central angle. Okay, arc length, again, we're in degrees. So arc length is equal to the fraction of the circle that I have, 37 over 360, times the whole circumference, which is 2 pi r, and r is 20. So again, put that into my calculator, 37 divided by 360 times 2 times pi times 20. And I get 12.9 with my 3 sig figs. Oh, I rounded this off, so I really should use the squiggly equal sign. 12.9, and that would just be centimeters. Okay, find the area of a sector with a central angle of 1.2 radians. Now we get to the easy formulas. Area is equal to, if you use the formula packet, area using radians is 1/2 theta r squared. 1/2 theta r squared. So that is 1/2. Theta is 1.2. R is 20 squared. So I can just do that. So I have 1/2 is 0.5 times 1.2 times 20 squared is 400. And I get 240. So 240, since it's area, it's units squared. My units are centimeters, so there it is. All right, arc length, again, since it's in radians, I can use the easy formula. It's just theta times r. So theta is 1.2, r is 20. So I could probably do that in my head, but let's go ahead and do it on the calculator. So 20 times 1.2, and I didn't put my decimal in. 20 times 1.2 is 24. Equals 24, and we're talking about the arc length. Length is measured in centimeters. All right, that's level 1, just using the basic formulas. Okay, level 2, this is using the formulas backwards. So given the area, you can find the radius or the central angle. So here I'm given an area, and I'm given the radius, and I want to find the measure of the central angle in both degrees and radians. Well, I think it's easier to use the radians formula. So area in radians is theta r squared over 2. So I'm going to substitute in my, sorry, what am I doing? I'm going to substitute in for my A and for my area, 744. I don't know theta, but I do know the radius. All divided by 2. So I'm trying to get theta by itself, so I'm going to start by timesing both sides by 2. So I've got 744 times 2 and I get 1488. So I get 1488 is equal to theta, and then 25 squared, what is that, like 525? I don't remember. 25 squared, 625, that's right. 625. So now I need to divide both sides by 625. So 1488 divided by 625, and I get 2.38. So 2.38, and that's my radians. So if it's in radians, you don't have to write units. You could write radians next to it if that makes you happy. Also, you could put a C. C stands for radians. Don't ask me why. I don't know. Look it up. Or you can just leave it without any units at all, because that implies radians. Okay, but now I need to change it to degrees. Well, I know 180 degrees is equal to pi radians. So if I want to change radians to degrees, I want the degrees on top and the radians on the bottom, so that when I multiply it by 2.38, the radians are going to cancel out. Radians cancels with radians. I'm going to be left with degrees. So I'm going to go 180 times 2.38, get that, divide that by pi, and I get 136. So that would be 136 degrees. Okay, so my answers are in degrees and in radians. So there's my degrees, there's my radians. Okay, I also could have run the formula using the area formula using degrees, but that would have been a lot more complicated, so I kind of like doing it this way. Okay, next, given an arc length and a radius, again, find the central angle. So I'm going to use the formula. Arc length is equal to the central angle times radius. So I know the arc length is 74. I don't know the central angle, but I do know the radius is 18. So all I got to do is divide both sides by 18, and I get theta is equal to 74 divided by 18. I get 4.11111111. That's 1/9. Okay, so in case you don't know that, these are real convenient to know what fraction this is. It goes 0.1 repeating, it's 1/9. 0.2 repeating is 2/9. 0.3 repeating is 3/9. 0.4 repeating is 4/9, etc. So that's 4 and 1/9. Okay, so that is in radians. So now I need to change it to degrees. So just like we did up here, I'm going to take that 4 and 1/9, and I'm going to times it by 180 over pi, because radians cancels with radians. I'll be left with degrees. So I still have it in my calculator, so I'm just going to times that by 180 and then divide it by pi. And I get 3.14. What? Oh, that's, sorry, I messed up. I'm like, how did I get pi? Okay, let's try that again. Somehow I messed up. Okay, so I got 4.11 times 180, that's that, divided by pi. There we go. That looks better. So I get my angle is 236 degrees, because I'm rounding it off to 3 significant figures. So theta is equal to 236 degrees, or 4 and 1/9 radians. There's my two answers. Okay, and on to level 3. So level 3, we're going to be finding the area. What does it say? The following shape is formed by a rectangle. It doesn't say what to do. Oh yeah, I can find the area and perimeter. So we're going to find the area and perimeter of this complex shape. Sorry, I should have written that where it says example also. So I'm just checking my answers real quick here. Make sure I didn't make any mistakes. 136, 238. Yeah, looking good. Okay, so for this one, sorry, back to what I was doing. For this one, a following shape is formed by a rectangle and a sector of a circle, and we know that theta is equal to pi over 6. Okay, so this is pi over 6, and we want to find the area and the perimeter. So let's do area first. I think area is a little bit easier for this one. The area of the rectangle is just going to be 8 times 5. So 8 times 5 gives me 40. And then I need to add to that the area of the sector. Well, they tell me the central angle, and the radius I know is the distance from the center to the edge, and since that's along the top of this rectangle, it means my radius must be 8. So my radius is 8. So therefore, the area is equal to 1/2 theta r squared, or theta r squared divided by 2. So, or you can write that as 1/2 theta r squared, whichever you prefer. So my area is going to be theta, which is pi over 6, times radius squared. So my radius is 8, and then times by 1/2. Okay, I can do it that way, or I can put it the divide by 2, whichever way you want to do it is fine. So on the bottom, 2 times 6, I get 12. Pi, 1 times pi times 8 squared is 64 pi. And it doesn't say if it wants an exact answer or not, so I'm going to go ahead and reduce this. 64 and 12, those can both be divided by 4. So that would be 16 pi over 3. There it is exactly. And if I put that into my calculator, 16 times pi divided by 3, I get 16.8. And what are my units? Centimeters squared. That's for this up here. Okay, and I can prove it to you that these are equivalent. Let's just make sure. 64 times pi divided by 12. Yeah, I got the same thing. Okay, so the top area is 16.8. The bottom area is 40. I'm going to add those together. So plus 40. So my total area is 40 plus 16.8, which gives me 56.8 centimeters squared. Okay, now I need the perimeter. So the perimeter means the distance around. So I've got 5, I've got 8, I've got another 5. This piece right here, this is the radius again. So that's another 8. So the only thing I'm missing now is I'm missing this arc length. So I'm missing that arc length, so I'll just go ahead and call it L because it's an arc length. So I need the formula for arc length. Arc length is equal to theta times radius, and I know both of those. I know the radius is 8, and I know theta is pi over 6. So I can reduce that. 6 and 8 can both be divided by 2, so I get 4/3 pi. I want to go ahead and be able to add all these together, so I'm going to change that to a decimal. So that's approximately equal to 4 times pi divided by 3, 4.19. So that's approximately 4.19. So my perimeter, I need to add all the numbers all the way around. So I've got 5 plus 8 plus 5 plus my arc length, which is 4.19 approximately, plus another 8. Okay, 5 plus 8 plus 5 plus the arc length plus 8, just around the edges. Add those together. 5 plus 5 is 10, 8 plus 8 is 16. So I have 26 plus 4.19. 26 plus 4 is 30, so my perimeter is equal to approximately, because I did round off, 30.19 centimeters would be my perimeter. Oh, 3 sig figs. 30.2 centimeters. If I'm doing 3 significant figures. There it is. Okay, that was level 3, because it was basically just using the formulas that we've just recently learned. Now this one, you're going to have to pull in your special right triangles or your Pythagorean theorem or some trigonometry to do this one. So I want to find the perimeter and area of this shaded region right here. So this is going to be a little tricky. So let's see what I have. AT is tangent. So we learned in class that that means that is a right triangle. OA is equal to 13. So this whole thing is equal to 13. And the circle has a radius of 5. So this is 5, and this is also 5. So find the perimeter, all right, of the shaded region. Okay, so if the whole thing's 13 and this is 5, I can do 13 minus 5 to get this. That would be 8, because 8 plus 5 is 13. And now I need to find this side, but notice I've got a nice little right triangle here. So my nice little right triangle, if I put it this way, so it looks kind of more normal, the short side is 5, the hypotenuse is 13, and I'm trying to find this side. So, Pythagorean theorem. 5 squared plus x squared equals 13 squared. So 25 plus x squared is equal to 169. Minus 25 from both sides, I get x squared is equal to, what is that? Is 144. Oh, how nice. Square root that, I get x equals 12. So this side is 12. All right, so I'm doing pretty good. So to get my perimeter, it's going to be 12 plus 8 and then plus the arc length. So to get the arc length, I need to do the central angle in radians times the radius. And, or if we'd rather work in degrees, we can do the degrees over 360 times 2 pi r. Okay, so we're going to use one of these formulas, so depending on whether we want to do degrees or radians. So I think most people at this point are more comfortable with degrees, so I'm going to go ahead and use the degree formula. But for those of you who want to try and push yourselves and do it in radians, you can set your calculator mode. Here under mode, you can set it to radians, and you can, the next process that we're going to do to find the central angle, you can use radians instead of degrees, but do reset your calculator if you're going to do that. All right, but I'm going to go ahead and do it in degrees. So I want to find this angle right here. That angle is this angle, since I flipped my triangle upside down. So this is my theta. So now to get that missing angle, since it's not a shortcut triangle as far as I know, it doesn't look like one, I'm going to have to use SOHCAHTOA. So I'm going to put my finger on my angle and see what I have. I have the hypotenuse, and oh, I actually found this, so I can use whatever I want because I know this is 12. But I'm just going to go ahead with what I have right now. So that's the hypotenuse, and 5 is the adjacent. So looking at my SOHCAHTOA, I have adjacent and hypotenuse. Adjacent and hypotenuse means cosine. So to get theta, I'm going to do cosine of theta is equal to 5 over 13. So to get theta by itself, theta is equal to cosine -1 of 5 over 13. So I'm going to put that into my calculator. Now this is where you could get the answer in radians, or you can get it in degrees, depending on what mode you're in. I'm in degrees, so when I do this, I'm going to get my answer in degrees. So 5 divided by 13. So notice I did cosine -1, okay? And I get 67.38. I'm going to take a bunch of digits because I'm not ready to round off yet. 67.380, and that's in degrees. Okay, so I'm now ready to find my arc length. Or I could have done this, you know, God, this is so much easier if you just use radians. I can change this to radians, so we can do it 2 ways. I think I'm going to go ahead and just change this to radians because I'd rather use this formula. Just radians times the radius. So if I'm in degrees, I can redo this again. If I go to my calculator and I change the mode, let's change to radians. And I'm going to do it again. Cosine, cosine -1, there it is, of 5 divided by 13. Now it's going to give me the answer in radians, 1.176. Okay, so this is the same thing as 1.176 radians. That's in radians. So now I can actually use this formula, which is easier. So the arc length is equal to radians, 1.176, times the radius, and the radius was 5. So my arc length is, I still have that in my calculator, so I can just times it by 5, and I get 5.88. So 5.88, and that would be centimeters. So now I can find my perimeter, because all I got to do to get my perimeter is I just need to add the other side. So it's 8, so it's 12 plus 8 plus the arc length. So 12 plus 8 plus 5.88, so which is approximately 12 plus 8 is 20, so just add 20 to that, and I get 25.88 centimeters. Okay, so I use the arc length formula in radians by changing my answer to radians. All right, area. In order to get the area of this part, this is a little bit fancy, because I know how to find the area of the sector, and I know how to find the area of a whole triangle, but to get this part out here, I'm going to have to take the area of the whole triangle and cut off. I'm going to have to subtract the area of the sector. So I'm going to do the area of the triangle minus the area of the sector. That's what I'm going to do. So the area of the triangle is base times height divided by 2. So I know my base is 12. So the area of the triangle is going to be base times height divided by 2. And then the area of the sector, so I have my angle in radians, so I'm going to use the radians formula, which is on the formula sheet, which is 1/2 theta r squared. I'm going to use that one. So here's the area of the triangle. Now I'm going to minus the area of the sector. So 1/2, 1.176, and the radius was 5 squared. And now I can just put that whole thing into my calculator because I'm running out of room. Or I could do them both separately. Oh, what the heck, let's do them separately. 1/2 of 12 is 6. 6 times 5 is 30. So the area of the triangle is 30. And then this over here, I'm going to go ahead and use my calculator. I have 1/2, that's 0.5, times 1.176 times 5 squared is 25. And I get 14.7. So minus 14.7. So I'm going to do 30 minus 14.7. Now I'm starting to wonder if I round it off too soon. Where's my radians? You know what? I might go up and add a few more radians to this. Let me see what I get. I got 15.3. I wonder if it's going to get me a better answer. 15.3, and that would be centimeters squared. I wonder if I get a better answer if I use that whole radians thing. So I'm going to do this again. 0.5 times, instead of typing this in, I'm going to go up and grab my previous answer for the radians, which was this one right here. So I'm grabbing that, and then that times 5 squared. And, ooh, did I mess something up? 1.176 times 5 squared. I got a totally different answer. So using more of the radians, I got 14.7. Ooh, that's kind of freaking me out. So I got 14.7 when I was being more careful. Oh no, I'm sorry. That was this. Never mind. Gosh, I'm freaking myself out. Okay, and then I subtract that from 30. So I'm going to do 30 minus that, and then I'm fine. 15.3. Okay, it rounds off the same way, whether I put the whole answer into my calculator or if I rounded it off a little bit earlier. All right, so that's it. My area is 15.3 centimeters squared for this shaded part, and my perimeter was 25.8. Oh, 3 sig figs. Just noticed it again. Just caught myself. So let's round that off to 3 sig figs. 25.9 centimeters. That's my perimeter. Okay, perimeter and area. Got 'em. Sorry I didn't give you much space there. All right, have fun with that.